All right, Miss Teasley here. We're going to talk about logarithmic functions. All right, so a logarithm for all real numbers y and all positive numbers a and x, where a cannot equal 1. So you have this log form here. So log form is going to have this word log written in it. And then we have our exponential. So log form, exponential form, we say log for short for logarithms. So when you look at both of these expressions, you have y equals log. That little a is base a of x is equivalent to x equals the base a to the y exponent. All right. So if you look above, it says expression log base a of x. So when you look here, log base a of x equals y. When you look over here in exponential form, y is the exponent. So the expression log base a of x represents the exponent to which the base a must be raised in order to obtain x. So logarithms in short are exponents. All right, so in summary. So let's kind of go back over this looking at the first example. So we're going to be writing from log form to exponential form. So if you look at the first example, part A, they give it to us in exponential form. In exponential form, the base of the exponent is 3. The exponent itself is y. So I write the word log. Since the base of the exponent over here is 3, the base of my log will be 3. Logarithms always equals the exponent. The exponent in exponential form is 4, so the 4 goes here. The other number that we haven't used, that's what goes beside the word log. So that's the log form of that exponential form. And notice 3 to the 4th does equal 81. So going down part B, log base 1/2 of 8 equals -3. Remember, logarithms equal your exponent. So here, the base of my logarithm is 1/2. So I'm going to write 1/2. The exponent is the -3, and that equals 8. And 1/2 to the -3rd power is equal to 8. All right, so going back here, so maybe this would be a time you can kind of pause the video and try this. You're just rewriting it from one form to the next. So if you want to pause and try, example C through F. All right, so hopefully you had a chance to just try those. We're just converting from one form to the next. So looking at part C, exponential form 10 to the 3rd power equals 1,000. The base is 10. The exponent is 3. So over here, I'm going to write log. The base would be 10. Over here, the exponent is 3. And the number that I haven't used is 1,000. So that's the equivalent form. So log base 10 of 1,000 equals 3. Part D, I'm going to go to exponential form. The base of my logarithm is 5. The exponent is 3. So this would be 5 to the -3 power equals 1 over 125. Part E, log. The exponent is 1. The base of the exponent is 12. And the number that I haven't used is 12. So log base 12 of 12 equals 1. This is a property. Log base B. So if you have a base and the number beside it is also that base, that's going to always equal 1. So this is a property that goes with this. Letter F, log base 6 of 1 equals 0. So here, 6 is the base. The exponent is 0. Remember, this is the exponent. And that equals that number here, which is 1. And we know that any number raised to 0 equals 1. Okay, so this is also another property. So whenever you have log of any base of 1, the answer will always be 0. All right, so that's just converting from exponential, converting back and forth between exponential and log forms. Now we're going to solve some logarithmic equations. And to solve logarithmic equations, we use exponential form. So we're going to use exponential form to solve. So I'm trying to figure out, okay, what is this base x? So I'm asking myself, the base x raised to what? Raised to the negative 2 power gives me 16 over 9. So rewriting this in exponential form. So this is going to be exponential form. The base is x. The exponent is negative 2. And the number that I have is 16 over 9. So to get rid of this negative 2, all right, you can just take the reciprocal of what's over here. That's how you get rid of a negative exponent. So I can just write this as x squared equals, when I flip this fraction, this is 9 over 16. I'm trying to get x by itself. So to get x by itself, I'm going to take the square root of both sides. When you're taking the square root of a fraction, you take the square root of the top number and the bottom number. Normally, I would put plus or minus signs, but the base of a logarithm can never be negative. So my answer is x equals 3 over 4. So 3 over 4 raised to the negative 2 power will give me 16 over 9. All right, so maybe stop and pause the video, try part B and part C. Rewrite it using exponential form and then solve for the variable x. All right, for part B, I'm going to just move down here. Let me see. I'm going to label this as part B. So part B is going to be log base 16, x equals 3 over 4. And over here, I'll do part C, log base 36, square root of 6 equals x. So again, I'm going to rewrite this in exponential form. The base is 16. The exponent is 3 to the 4th, and that should equal x. So 16 raised to the 3/4 power should equal x. So kind of doing like a circular motion. To get the value for x, I just need to figure out what 16 to the 3/4 power is. This is the same thing as a 4th root of 16, and whatever I get, I'm raising it to the 3rd power. Well, the 4th root of 16 is 2. So this is 2 to the 3rd power, and 2 to the 3rd power equals 8. So that's how you solve a log equation. Part C, same thing. I'm going to rewrite this in exponential form. 36 is the base. The exponent is x. So 36 to the x power is going to equal what's beside it, which is the square root of 6. So I'm trying to figure out what is the value of x. 36 to what power can give me a 6 back? Well, is it the square root of 6? All right, so 36 to what power gives me the square root of 6? Well, let's figure that out. Let's use what we did before when we were solving exponential equations. We're going to equate the bases. Well, 36, and I see a 6 over here. 36 is 6 squared. All right, but don't forget, you still have the x beside it. So I'm putting that x from here beside my 2. So 6 squared is 36. And if I go over to the other side, well, the square root of 6 is the same thing as 6 to the 1/2 power. So notice now your bases are the same. And so if you remember from exponential equations, since my bases are the same, once I get to this point, I drop my bases and I equal the exponents. So these are the same. So to finish this off, I'm going to say 2x equals 1/2. And then to get x by itself, I'm going to divide both sides by 2. When you divide a fraction by a number, it's the same thing as multiplying by the reciprocal. So 1/2 divided by 2 is the same thing as 1/2 times 1 over 2. So x equals 1 over 4. All right, so now we're going to graph or look at the graphs of log functions. Logarithms and exponents, logarithmic functions and exponential functions, they're inverses of each other. So let's make a note. So log and exponential functions are inverses. All right, so if you look at this first example, they have this graph f of x equals f of x equals log base 2 of x. In this example, the base of the logarithm, all right, is 2. So a equals 2. So whenever I want to graph a log function, I always go back and look at my exponential function. So if you remember from exponential functions, whenever you have the base a, you have those 3 special points, all right, that lie on the graph. And here for logarithms, it flip-flops. So here, if you remember for logarithmic functions or for exponential, when the x value was -1, the y value was 1 over a, where it flip-flops. So now it's 1 over a comma -1. All right, so let me go back over that. So let's go back to those points that we talked about in the last section. So for exponential functions, right, you have the points -1 and 1 over a, 0, 1, and 1a. So in this example, a is 2. So if a equals 2 in exponential form, the base of the exponential form is also going to be 2. So if I had to graph these points or find the points on the exponential function of this graph, so this is x equals, all right, and this is y equals just 2 to the x power. So using what I have here above, at -1, when I take the reciprocal of a, I'm going to get 1/2. At 0, the y value is 1, and at 1, the y value will be a, which is just 2. So that's how the graph, those are the points that would be on the corresponding exponential function. Since they're inverses, if you remember inverses to find inverse points, you just flip-flop x and y. So let's look over here at these values. I have -1 and 1/2. When you look at it in log form, it's 1/2, -1. Exponential graph is 0, 1. So over here in log, it's 1, 0. And then on the exponential form, it's 1, 2. All right, so x value is 1, y value is 2. But notice here it's 2, 1. So you could use the corresponding exponential values to help you solve this and then flip-flop it to get your values. Or if you just want to make a note that these are the 3 values that's going to be on your log functions. All right, in this example here, we have a log function. The base a equals 2, so this is when the base is greater than 1. The domain of this function, all right? So the domain, so notice since they're inverses, when we found the inverse of an exponential function, in this example that I have y equals 2 to the a, this would be exponential growth. In exponential growth, the domain was all real numbers, so let's just make a note. This is for this. The domain would be all real numbers. And the range of this exponential graph would be from 0 to infinity, all right, because it would never cross the x-axis. Well, since they are inverses of each other, it flip-flops. So in this example with the log function or the corresponding log graph, the domain of it is actually going to be from 0 to infinity. And the range is going to be all real numbers, so -infinity to infinity. All right, so or you can just look at the graph, and as you see that the graph never hits this y-axis. So it goes from 0 to infinity. If you read the graph from left to right, and as far as the range, it goes from -infinity to +infinity. All right, so f of x equals log base a of x when a is greater than 1, like we have here in this example. In this case, your y-axis is a vertical asymptote. So with exponential functions, you have a horizontal asymptote. With log functions, you're going to have a vertical asymptote. The graph passes through the point 1 over a negative 1, 1, 0, and then a1. Right, so that's the log function that corresponds with exponential growth. All right, now you have the log function that corresponds with exponential decay. So here your a value is 1/2. You're going to have these 3 points here. So remember, on your log function, just like we did before, you're going to have your 1 over a and negative 1. Remember, 1 over a represents reciprocal. One, 0, and a1. All right, so if you notice here, the first point, the 1/2, when you take the reciprocal, the y value is going to be negative 1. So the reciprocal of 1/2 is 2. So notice how at 2, my y value is negative 1. This is the reciprocal of a. At 1, the y value is 0. And at the actual a value, which is 1/2, the y value is 1. So those 3 points will lie on your log graph. The domain for this graph is going to be from 0 to infinity. The range is all real numbers. All right, this is when your a value falls between 0 and 1. So when a is less than 1 in exponential form, we call it exponential decay. In this example, remember with exponential decay, you have a horizontal asymptote, which is your x-axis. Well, with log functions, you have the y-axis, which acts as a vertical asymptote. All right, 1 over a goes with negative 1, 1 goes with 0, and a goes with 1. So we're going to use these 3 points to help us actually sketch the graphs of a log function. So what I'm going to do is the first time I'm going to do it the way like I would normally do. If I had to graph a log function, I would start off with the exponential function and then flip-flop the points. So the first time I'm going to graph it using my knowledge of exponential functions, and then when I get to part B, I'm just going to go straight to the points that I have listed above. All right, so here, starting with the first one, I have this log function. A is 1 over 3. So in exponential form, when a equals 1 over 3, that means this is going to be exponential decay. So I'm actually graphing the exponential form y equals 1 over 3 to the x power. So I will start off with my table. Y equals 1 over 3 to the x power. Put a parentheses around that. So starting off at negative 1, when I have x equals negative 1, I take the reciprocal, so that's going to give me 3. When my exponent or x value is 0, anything raised to 0 is 1. And then when my x value is 1, I just get my base of 1 over 3. So this will be the point for the exponential form. Log and exponential functions are inverses. So the log form, which we have above, which is y equals log base 1 over 3 of x, they're inverses. So I'm going to switch x and y. So when I graph this, I'm just going to flip-flop the points that I have above. So it's going to be 3, negative 1, 1, 0, and 1 over 3, 1. So these are the points that I will use to actually graph this. So when I have an x value of 1 over 3, we'll say this is 1. So 1 over 3 will be here. So 1 over 3, you have a point here. At x equals 1. Hold on, let me back up. All right, so this is where I'm graphing. I'm graphing here, these points. So let me put some labels. So we'll say this is -1, 0, 1, 2, 3. So at 3, I have a y value of -1. So we'll say that's here. At 1, the y value is 0. And at 1/3, which would be about here, the y value is 1. So here. All right, so this is your graph. The y-axis acts as a vertical asymptote. All right, so that's the graph. All right, I'm going to put this in decimals just so you can see it, and then we'll come back and look at part B. So log base 1/3 of x. So the functions, let's do y equals. To get log, you have to hit this function button, go over to miscellaneous. You want to choose the one that says log with a little a there. My base is 1/2. Oops. So I guess I need to put parentheses around my base. Let's see. Go back to this. I'm going to change it because it's not letting me put in the fraction, or at least I don't know how to do it. So instead of me putting 1/2, I'm just going to change it to 0.5. So 1/2 is the same thing as 0.5, and it's just x. So let's see. Y equals log. I meant to put x there. All right, there you go. There's your graph. Okay. Go to my table. So you have the points here. The base was 1/2. Let me delete these. Was it 1/2 or was it 1/3? Hold on. Oh, it's 1/3. All right, let me change this. So 1/3, we'll say it's 0.3. All right, I'm just going to scratch that. All right, I'm not going to put all that in there. We'll look at it when we get to the other example. Let's just go straight to part B, and I'll come back and look at decimals again. Just wanted you to see, you saw that the graph matches up. So for part B, instead of me doing all that work with the exponential and then, flip-flopping the points, if you just know that on a log graph, you're going to have these 3 points. All right, you can also graph a log function. So if you remember, in this case, in this example, a is going to be 5. So based on the table that I have above with the 3 points that always lie on your log functions, you're going to have 1/a -1. Well, what's 1/a? It's the reciprocal. So when x equals 1/5, my y value is -1. When x equals 1, the y value is 0. And when your a value, which in this case is 5, your y value is 1. All right, so this is 1/a. This is just 1, and this is just a. So just making a note. And just with those 3 points alone, I should be able to sketch the graph of this log function. So at 1/5, we'll say it's here. The y value is -1. At 1, the y value is 0. And then at 5, the y value is 1. So we'll say about here. So your graph looks something like this. All right, so I was having issues with putting a fraction as the base for the log function. So let's see how it works when I do log base 5 of x. So y equals function log base 5 of x. So there's your graph. Let's go and make this a table. We have 1 divided by 5. So 1 divided by 5 is -1. That's the point we graphed. Then we had, when it's 1, 1, 0, and I'm going to change this to 5, 1. So here are your points. Those are the 3 points All right, and that's it.